Okay, in this video I'm going to go over some of the hardware that makes my sonar board possible. So first off, let me talk about the board layout itself. So there are two circuit boards in my design. They're stackable, there's an analog board on the top, and a digital board on the bottom. The reason that I did it this way is really it's for two reasons. One is for function. This has to fit inside of a small submarine, and size constraints are always a reality for us. So stacking two boards on top made a lot of sense for our design. The other reason, which is really important, is I wanted to keep my analog and digital components really isolated from each other. For example, the requirements for this board is that we had to be able to run this circuit board off of either a 24 or a 48 volt rail and step that down to 5 volts. So what we have here is a wonderful chip from Texas Instruments that takes the voltage down from 6 volts, anywhere from 6 volts to 50 volts, and can step it down to 5 volts. This simple switcher, which they created, is great, but it does produce a lot of ripple noise. So we wanted to keep that far away from our analog, which is recording signals as weak as 1 millivolt or less. So that was the big driver for separating these two boards. So let me walk you through the design process in this digital board. It's relatively simple. Everything on this board is here to serve the DSP. This is a TMS320 F28379S single core DSP that Texas Instruments just came out with and is really great. What we have is two LDOs, 3.3 and 1.8 for the GPIO, as well as we have an FTDI chip for talking with the main computer, and then up here are simple reset and boot mode switches. Filtering on the bottom, we have a series of 0.1 microfarad caps that go along the outside. Relatively simple for this, and yet very, very powerful.